One of the things I like to do at the start of any presentation, and for what it's worth, this is not just public, but even like inside an organization or what have you, and I think it's a good practice for y'all as well, is I like to define some of the words that have multiple definitions. It's funny because I know Andrew spoke a couple hours ago, and we've actually joked about this a little bit. On one hand, definitions don't really matter, and they don't. It does not matter that the world agrees on a definition of DevOps. What I think is important is that in smaller conversations, that it's more clear among a group. So like, I'm going to go through, I'm going to show you the definition I use for DevOps, the definition I use in continuous delivery. The purpose of this is so that you know what I mean for the next 30 minutes when I'm doing the presentation. It's not for you to necessarily adopt it or what have you, but it's so that you know what I mean. And I do recommend that for your meetings. Like, if you say, yes, I've written the unit test, does everybody know what that means? If you say that, your definition of done and what have you. So with that, I will go on and do just that. So the first one, when the organizers reached out to me and they said their main theme was resilience, I was really excited about that, because really the whole purpose that, at least that we do this, is to be able to adjust easily. So, and I don't mean resilience engineering here or engineering practices and those sorts of things, but when I'm thinking of resilience in this thing, it is the ability for your organization, to the number 2 one there, to recover from or adjust easily to misfortune or change. And so this happens all the time, right? I mean, I'm going to steal a little bit from a later slide, but we're in a major event right now, of course, globally, but this is not going to be the last time. Organizations do need to be able to change quicker. So first off, this is my definition of DevOps. So to me, DevOps it's working together. I think Ahmed said many of the same things. It's about how you operate as an organization, how you work together to imagine, so come up with the requirements, deploy and operate a system. And this is why I also joined the previous speakers in saying I'm not a fan of like a DevOps team or even DevOps tools. If for no other reason than it's just too broad. If I say DevOps tool, what does that mean? Is that automated testing? Is that deployment? Is that observability? It's just too broad. So I think of DevOps as the culture. For continuous delivery, Jez Humble and Dave Farley, when they were working for Thoughtworks, gosh, 13 years ago, I guess now, wrote a book called Continuous Delivery. And this is Jez's short version of the definition of continuous delivery. So it's the ability to get changes of all types. So it is features, configuration changes, everything. Some keywords here that people skip a lot. It's into production or into the hands of users safely, quickly, and in a sustainable way. So it is safely and quickly, but it's not just about speed. I know a couple people referenced the State of DevOps report. Many years ago, their #1 metric for their highest performers was how often you deployed. So did you deploy multiple times per day or once a month or whatever it happened to be? I was never a fan of that metric, because how often you deploy should be a business decision. So for example, I'm an amateur photographer and I use Adobe Photoshop, which is a fairly large program. If they were to give me a new release multiple times per day, that would be really frustrating, because that's a huge download, a long install process, etc. But my understanding, I don't work at Adobe, my understanding is they could deliver at any time. So it's keeping the thing in a deliverable state. Now, for your particular product or service or application, that might mean continuing, multiple times per day, very, very short cycle times, etc. But I much prefer the newer way that the State of DevOps report talks about it, which is deploy on demand. To me, that's the measure of continuous delivery, is can you deploy when you want to or when you need to? So can you react to change? So if we tie these all together, the idea here of being prepared is we need to be able to get changes of all types into the hands of users. So these are features, but these, again, could be security fixes, those types of things, anything. It requires that as people, as organizations, that we work together. It doesn't matter if your title is a QA engineer or developer or operations or system administrator or what the title is. It's a team working together towards a common goal so that we have the ability to recover or adjust easily to misfortune or change. And I do want to stress that it's not just when things go wrong. I mean, there's changes in the market, et cetera. I work a lot on technology strategy now. We were having to talk about augmented reality of all things. And there are some manufacturers out there, some companies out there that are talking about creating physical devices. And if they do, everybody in that industry is going to have to react. And so how quickly can they react? How quickly can they update their platform so that they run on these new devices? So it's just as much about business as it is about misfortune. So really what we're trying to get to is this continuous cycle of being able to get feedback, test hypothesis, going back. Dave Farley, the other author of the Continuous Delivery book, talks a lot about the scientific method. If you don't follow Dave Farley on YouTube, please do. There's lots of good little snippets about things. And the idea here is to come up with a hypothesis. If we make this change in our product, it will have this effect on our business. So sales will go up, whatever it happens to be. And then you can deploy that and test the hypothesis and measure it and get that user feedback and then plan and repeat. Fast feedback and closing that loop is the key to resilience to the market. So, why is this important? I think this is probably pretty obvious to anyone that's viewing a DevOps Days, frankly. But I want to go through it anyway of why we talk about these things and why they are important to us. The first thing here that I chose, and I did this on purpose, you notice that it's a fairly rudimentary graphic. This is from a sales deck that we created at Thoughtworks. I years ago worked on a continuous delivery product called GoCD. And we were trying to teach people what is continuous delivery. So this is from a sales deck from 2009, which gives you an idea of how long as an industry we've been struggling with this. And really, it's that Agile, in all of its various flavors, whether it's Scrum or extreme programming or SAFe or whatever it happens to be, did not really address what we call the last mile, or the getting it into the hands of users. So for a long time, those of us that were doing Agile more years ago than I care to admit, were all about the definition of done being that we have shown this feature to the product manager or the sales team or somebody like that that's an internal advocate. But it wasn't really in the hands of the customers yet. So we really weren't getting feedback on, did our changes make a difference? Did they help our business go up? Did they make it more reliable? Did they whatever the goals were, we weren't getting real feedback for that. So for us, at least, continuous delivery was the end of, I don't mean that, I don't want to put it this way, the part that Agile didn't deliver. I don't want to say the end of Agile because it's not replacing Agile, but it's the part that Agile didn't do. Agile didn't actually get into the customer's hands, and that's where the continuous delivery comes in. And then again, to state the obvious, we all know right now why we're talking about resilience and that kind of stuff. But we need to remember that this is not the first disruption, and it will not be the last. Years ago, I was working on that same product, there was some fairly major security issues with an SSL library. And it really affected lots and lots of places, and people had to react quickly. And there were organizations that were able to update their applications and do deployments and so forth quickly. And there were those that were not. Our products, we were able to get out in a few hours. And so they came out of nowhere, even though apparently it's an issue that had been in the SSL library for years, but we have to do it, which is reacting to security issues, like I said. So this is not just your organizational ones, although you will have these too. It's unfortunate, but there are people out there, very technically talented people, who are trying very hard to get into your systems. And so when something happens, not if, when whether it's yours or a library you're using or what have you, you need to be able to react to it quickly. If the rest of your application is not in a deployable state, if you can't deploy right now, if you have to wait till a feature's done or a dependent microservice is done or what have you, then you can't react as quickly. And then, of course, the competition is not slowing down, right? So the people who are after your same customers, they're going faster. There's the idea now of how do I put this? The platform model, if you will, the platform business model of creating a connection between producers and consumers. So as an example, companies like Uber and et cetera, they don't own any cars. And so they're connecting drivers with people that need a ride. And that's, a platform business as opposed to a technical platform. They have an advantage over someone who builds cars because they need to be able to get supplies and so forth. And so your competition isn't slowing down. So anything you can do to speed up your delivery is a good thing. Now, it's interesting because I'm not going to give a spoiler. I stole one of Andrew's slides for the end because one of the things that you'll hear a lot from people that have been doing this for years is that there are certainly technical aspects to this, but this isn't a technical problem. And so in my presentation, I have an entire 2 slides on architecture. Architecture is not a dirty word. I joined, again, I caught the last few minutes of Anders. I joined him in the frustration over the Agile community and others making it a dirty word. Architecture is an important concept of how you're going to design things and go forth. My boss, the chief technology officer of Thoughtworks, and a couple other folks wrote a book called Evolutionary Architecture, which is about making sure your architecture can evolve with technology changes and business and changes and so forth. So it is very important, but I don't want to focus on it. That said, the number one thing that I want to talk about is these small deployable pieces. And so I know Ahmed talked about this and others. But the idea of microservices and technologies like this, small componentized architecture, these are not just buzzwords. I know they're used that way. I know there's companies with marketing around this, selling you their products, et cetera. But the idea is that it's a small unit of work that can be deployed independently. That's absolutely key. If your service has to be deployed at the same time as another service, so maybe you have a customer and a billing service, for example. If they have to be deployed simultaneously, it's not a microservice by definition. It must be independently deployable. With, again, the bare minimum of centralized management. So we will, generally speaking, it depends on the client, of course, use like event-based architectures. So services don't call each other directly. They subscribe to an event queue. So, hey, I've created a new customer. Oh, okay, the address service needs to pick that up and add that to the database so that they can be both independently deployable and have some resilience, some technical resilience for communication errors or what have you. And so don't be afraid of words that have turned into buzzwords, the DevOps, continuous delivery, et cetera. There are core foundations that are very, very important. And from an architecture perspective, if you do want to be able to deploy right away, your individual pieces have to be independently deployable. One of the things that we see people do from an architecture in the microservices perspective is try to do big bang. They say, okay, I have this huge system and I'm going to spend the next year and a half breaking it out into microservices. I don't recommend that. Our chief scientist, Martin Fowler, wrote this article, I want to say it was about 16 or 17 years ago, about the Strangler fig application. And I don't want to go into deep detail, but I'll share URLs with the organizing team later so that they can share them out and so forth. But the idea is that these Strangler figs would take and replace parts of a tree at a time. So when you have your monolith, let's say that I need to be able to scale up the reservation service because we're in the middle of COVID and now people are reserving things remotely or whatever it happens to be. There's patterns out there for replacing just that part and having them call into the monolith. So don't try to do big bang. Don't try to re-architect the whole thing. Do the most important things first. There's a lot more I could go into on architecture, but I'm purposely not, because again, I don't want you to think that DevOps is a technical problem. It's certainly, technology obviously contributes to it, to be able to automate the things and so forth, to have the proper architecture that is testable, that is independently deployable. But please don't focus just on that. Now, 2 slides on engineering practices. Generally, the most contentious part of the talks I give, the next one I'm going to talk about. But for us, this has been really key into keeping things deployable at any time, to make sure that we can. And for people that don't practice it, it might not make sense. They might think the opposite is true. And that is truck-based development. So I would say, and being a little bit dogmatic here, if you're doing things like long-lived feature branches, you are not doing continuous integration, full stop. You might be doing pretty good automated build and test, you might be doing automated deployment, et cetera, but it's not continuous integration, for whatever that's worth. Again, words don't necessarily matter, but now this is not to say that you never branch. In today's world of distributed version control systems, heck, if our documentation's all in Git, and if I'm going to update one of our reports, the first thing I do, of course, is a Git clone and create a local branch and work on it. But we're pushing back to master at least once a day. There's a lot of folks who believe, and I understand the logic, that keeping features in progress in their own branch makes the master more deployable, that I can deploy it at any time because that half-done feature isn't in there. And I understand that logic, but the truth is that merging back in and all of those things becomes more of a hassle than it's worth, frankly, and it's much, much harder. Instead, what we do is, well, one of the concepts of the way we do this is something called feature toggles, and this is not new. There are products out there to do that. You can do it yourself, et cetera. But the idea is that if I'm going to work on a new feature, instead of creating a long-lived feature branch, what I do is create a toggle point or a setting that says, turn my new feature off. And so by default, the application is executing the old code and not executing my new code. To test it, so in my pipeline and other places, I will toggle that feature on so that I can test the incomplete feature. But should I need to release, I can release and I don't have to worry about it. There's code in the application that's not being executed. And so, that's why things like shifting left security and the term DevSecOps, which for what it's worth, I don't use the term DevSecOps because I think it lets DevOps off the hook or makes it think they're not responsible for security. They are. I think everybody should be doing security as well. So to me, DevSecOps and DevOps are virtually the same thing. But we need to make sure that it's deployable and safe in that way, but I can turn it off. I used the example earlier when that OpenSSL issue came out. That affected the tool set that I was working on at the time, which was an on-premises tool. People downloaded it and installed it. And so to address that issue, we had to create a new download. This was many years ago, and we were right in the middle of a really core change to the application. And had we not had everything in a deployable state, it would have taken us much, much longer to react to that. But we were able to do that and get a release out in hours where people could download it. And little did they know, if they had gone in and changed the configuration to a different core library, that it would have used the new one. But it didn't stop us from being able to deliver. And it's through things like feature toggles that we do that. Okay, so that was my 4 slides on technology. Now I really want to talk more about what really, to me, matters the most, and that's the organizational structure and the team structure. And again, there's going to be a little bit of repeat information here, but I think that's probably good. So first off, I love to reference this quote. Werner Vogels, who, for those that don't know, is the Chief Technology Officer for Amazon, in 2006 gave an interview where in the middle of the interview, this was not the main topic, he mentioned that they had a policy at Amazon of you build it, you run it. So if your team is building a service, then they're going to run that service. So they're going to do the troubleshooting, they're going to do the support, et cetera. A lot of people have taken it at the time, and frankly, in the 15 years following, to mean that this was a way to get rid of operations or to get rid of the support teams or to handle tickets better or what have you. And it definitely was not. If you read the entire article, and I have a link, and again, I'll share it later, is if you put it in the context of the quote, the reason that Amazon did this and the reason that we do this today is because it puts the software development teams in day-to-day contact with their customer. So if they make a change and they want to know, did product sales go up or down, they can measure that and react. They can get the feedback. They can test hypothesis. It's again, and I said this 15 minutes ago, I know, it's about that feedback loop. It's about putting the team, putting the people that are making the modifications closer to the customer so that they can react and so that they can experiment. So again, I highly recommend whenever you're seeing the little snippets of quotes or what have you, try to find the context. So what does this mean in reality? And I think others have talked about this, but if we look at the quote unquote traditional structure of development teams, and then we have testing teams. I use testing at a high level. So this could be normal what we think of as QA, functional testing, that kind of thing. It could be security, it could be compliance, it's just verification, if you will. And then we have the operations team, and we have that wall in between. And the problem here isn't just the handoffs themselves, the physical handoffs and the feedback loop. That's, of course, as I mentioned, a huge part of it. But the problem is also the communication. I don't know why we're doing that feature. So if I'm testing it, or if I'm checking its compliance, or that kind of thing, if I don't know why it was done, I don't have the context, then it's harder for me to know what exactly to check and how to give useful feedback and so forth. So it's more about the communication than the handoffs. The handoffs are important, but it's more about the communication. Now, one of the things that we see people do all the time, if you didn't notice, if you weren't watching closely, the slide did just change, but I changed operations teams to DevOps team. No, okay, renaming your operations team DevOps team and giving them a automation tool, a pipeline tool, or what have you, is absolutely not the solution. So it's not just that we're upskilling the folks who used to be responsible for different things. That doesn't work. And others have mentioned, the fallacy of DevOps teams. And so this is where we talk about products over projects, and it's cross-functional. So I get those skills on the team. Now, I want to be clear here that they're never going to be experts in everything. And I'm going to go into that a little bit in a bit. But the point is that actually, let me back up and I'm going to tell a story. What led to the book, the continuous delivery book, being written? At Thoughtworks, we had a project, I want to say it was 2005 or 2006, where they were writing a bunch of software that was Java, and they were writing on Windows laptops. And then they deployed it after months of authoring to a Solaris production environment, which was the intended target. And it simply did not work. It wasn't that there were bugs. There were some things with the way it used a shared file system, and it literally wouldn't start. And so, oh my gosh, panic. And so they worked up to a system that would test on a production-like environment more often. Jez Humble, Chris Reed, and Dan North wrote a white paper called The Software Production Line as outcome of that project. But if they had had somebody on that team who their responsibility was not necessarily feature development, they weren't a front-end developer by trade or by education, but if they knew Solaris a little bit better and they had said, whoa, time out, if we do this that way, it's not going to work. Oh my gosh, okay, we change this. This cross-functional skill set can help alleviate problems before you even see them. This is also why I'm talking about roles here, but also from a diversity perspective. Diversity and having wide ranges of diversity of ethnic and gender and all those types of things. Those are important, not just because it's the right thing to do, which by the way it is, but also to get those viewpoints on the team and think about that with everybody's own biases, whether conscious or unconscious. So it's incredibly important that we have diverse cross-functional teams. So like at Thoughtworks, we don't have DevOps teams. We don't have pipeline teams. We have software delivery teams. You can't hire Thoughtworks, and you shouldn't hire anybody to help you do the DevOps or to create your pipeline. What you want to do is you're really changing the way you deliver software. And so it becomes just part of the way you work. So as I mentioned, we don't have DevOps engineers. We don't have those kinds of things. That's just the way we make software. We assume that it's going to be cross-functional, that we're going to have automated testing and deployment and those types of things. And it's just how we do business. Now, as I gave a little bit of spoiler out here, this does not mean that the teams need to be able to do everything, okay? When I say a product-based team, what I mean by that is people that are working in a product mindset. And I'm going to give a couple examples at the end, but we're responding to customer needs, data-driven customer needs. We're reacting quickly to the market, those types of things. But there's no expectation, and from me at least, that every team is going to have somebody that has deep Kubernetes knowledge, or really deep security knowledge even. So you still are going to have other teams inside your organization. They could be platform teams, so from a technical platform, the people that actually do have the deep Kubernetes knowledge, that sort of thing. And by the way, your platform team might be employees of Google Cloud or Amazon or Azure or something like that. But you do have people that's their expertise. I hope they're working with that product mindset of listening to their customers, which are your development teams, about what features do we need in our platform and what capabilities do I need to enable. You will still have compliance needs. There are all the regulations globally about customer data and financial data and so forth. And again, you're never going to have the deep expertise. And so you want those out there. From a continuous delivery perspective, one of the biggest anti-patterns, and actually Jez Humble, the author of that book, wrote an article, again, about 11 years ago, is people making very long, linear, so single pipelines. When you have these other teams contributing, please take advantage of your tools. Every tool on the market does this now, to do testing in parallel. So what do I mean by that? Development team, feature team, whatever your name is, writes some code, they commit a thing, an automated process kicks off that runs, something like unit test, does a basic build, fast test, is this even a viable candidate? When that happens, you can kick off multiple things in parallel. So you can have the security test that the team's responsible for, because again, we do need that early. So I can have container scanning, library checking, supply chain checking, those kinds of things in the main pipeline. But then there might also be additional security concerns that those tests are authored by that extra team. Those can run in parallel. Compliance checks. Did I open a port I'm not supposed to? Am I storing a string that looks like a credit card? Those types of things, again, might be in the development team's pipeline, but those tests might be managed by a different team. But don't put them in parallel, because I don't want to make the next step in my fictional example here. Like, let's say now there's functional tests. I don't want to wait on the functional tests until somebody else's tests are done. Okay, because I want fast feedback. And so there's no reason to run all my additional compliance tests if the functional tests are going to fail. There's not a lot of reason to run the functional test if all the compliance tests are going to fail. But I can run them in parallel. And then what you want to do is make sure that everything has passed before we go through and deploy to production. And so the idea there, again, is to shorten that feedback loop. I'm not a fan of you see people metrics out there like, I can get from code commit to production in 3 minutes, or whatever that time period is. That's great if you can, if you have a small service and you really are doing all the security and compliance. But the truth is that deploy times from code commit to deploy in seconds or minutes are probably not required for the vast majority of products, platforms, applications that you're working on. Now, should you have an emergency process that does that? Perhaps. But if your pipeline is taking 10 or 15 minutes and that's a short enough feedback loop that people can react and they still have context, that's fine. Please don't optimize for the wrong things, okay, is all I'm saying. And then I know this is everywhere this year, and I know State DevOps Reports, talks about it a lot. But I did this tweet a couple of weeks ago where I'm also a fan of the team topologies thing, because it talks about things like cognitive load, and it's not just about capabilities and training and that sorts of things, but how many teams can any one team think about? And so there's no one thing that you do to do the DevOps, if you will. But if there was one thing, it would be organizational structure. It would be how you set up your teams. And so I do recommend the book. And then I put this slide here that it's about the people. But as I mentioned, I watched Andrew's talk and I was reminded that it's not really the people. And so I sent him a direct message real quick and got permission, but he's absolutely right that it's socio-technical. It's about how the people work with the technology and how those teams are structured and so forth. If you require data for this, which is certainly a lot of people, you certainly want verification. Another reading, if you will. Google did a thing years ago where they said, we want to try to identify the commonality between our highest performing teams. And they, I imagine, assumed that it was going to be, oh, they know the programming language really well, they know the deployment targets really well, et cetera. And it actually turned out to be psychological safety. It turned out to be that safety of with my team saying, oh, I tried this and it failed, or I can't work on this right now because I'm just not in a good state of mind. Those types of things are the #1 in their study indicator to team success, and I would agree. Now, as much as I wanted to show you that data, I believe with Dr. Manns and Dr. Rising, the authors of this book called Fearless Change, that for the most part, people are not data-driven. So if you're trying to do this change in your organization, you're trying to get people to change the way they work, you're trying to get people to learn skills that they don't know, it's scary. It should be scary, okay? Just telling them, hey, we will be able to go from idea to market in 40% less time. All this data, it's not gonna make them do it. You really wanna talk to people at a human level. And so I highly recommend this book, Fearless Change. It's a patterns book. It just goes through ways in organizations that you can affect change, that you can communicate with people and understand what's driving them and how to make it important to them. And so I'm going to end with a couple examples of where we at Thoughtworks have implemented some of these things. And I do not mean this as a Thoughtworks advertisement at all, but I just wanted to demonstrate that this does work at very large scales. A lot of people think that DevOps continuous delivery, oh, that's great if you're a startup or you're a small team or what have you. But we really do try to apply these, and you can apply them too. So the first example is just a train aggregator. So in the United Kingdom, if you want to catch a train, this is a company that you go in and you load up their application. It shows you when there's a train from London to Manchester or what have you. They had an existing monolithic application that just would not scale. So if they needed to do new features, and the train companies, by the way, the carriers, I'm sure you all know this, they're constantly changing the capabilities, what they offer, the classes of service, the lines, et cetera. They really couldn't react to it. And so we went in and helped them with all these kind of things that we've been talking about, but mostly here, and I know this is a lot of words and you don't need to read all this or whatever, but in the middle you see there, we adopted the practice of data-driven feature prioritization. And so the idea is, it showed them how to do autonomous teams and then enabled them to say, okay, here's the data that's coming in. These are the features that are most important. This is where people are not able to book. These are where people are having problems. This is where we should react. And it was very successful. And then the other example, kind of close, Delta Airlines with their mobile application. When we create a psychological safe environment, when you tell teams, feel free to experiment, come up with things, think, I mean, it's a cliche, but think outside the box. So think about things in a way that you wouldn't notice or think about most of the time. When we're not just on this project, but other projects, and this was, gosh, I want to say 8 years ago or so, they were having a real problem with mobile applications in general. Everybody was going to mobile. My partner, if it doesn't show up on her phone, no, she never turns on her computer. But the frameworks out there really didn't enable this very well. They were rewriting everything every time, et cetera. The team actually went out and invented a mobile development framework called Calatrava, which you can find on GitHub if you're interested, that helped them deploy to different types of stacks at the same time with the same functionality and lower the reinventing of the wheel, or lower the times had to rewrite something. So these teams, that wasn't their goal. Their goal was to build a mobile application, to let people upgrade their seats and that sort of stuff. But it turned out that because they were the closest to the customer, they were seeing the feedback, they were trying to do the communication with the systems and so forth, that what enabled them was inventing, and please don't invent a new framework for everything, but in this case, what enabled them is the ability to say, hey, this is an architectural problem. We're going to go create this thing so that people can build these things and we can shorten the time to market. And it's been hugely successful. So I know I've said this a few times, but I do want to close on this. I know that we're all reacting to a global pandemic right now. I'm sitting at home instead of on a stage in front of you. I can't wait to get back on a stage, or I should say back to having conversations with people is a better way to put it. This is not the first time we've had a disruptive event. It will absolutely not be the last. And so it's incredibly important that your organization prepare for this change, to react to the market, to react to anything from political to economic to global pandemics. With that, I will say thank you.